This is RD Sharma Solution Class 12 Chapter 18. We are taking exercise 18.5 of Maxima and Minima. Now these are the questions based on sentences, English sentence language, and then we have to use those sentences to form the actual thing which we have completed in 18.1 till 18.4. We have to form the expression using these sentences, and the rest remains the same. So we have to determine two positive numbers whose sum is 15 and the sum of whose squares is maximum. Now this first line is determine two positive numbers. So the numbers has to be positive. It's not saying what kind of numbers, just two positive numbers. And sum is 15. Sum is 15 if you take x as one number, the other as y. The sum should be 15. X is greater than 0, y is greater than 0, that I already explained. So now you can take one as x and one as 15 minus x, because y from this expression is simply 15 minus x. Then we have sum of squares, so x square plus y square. X we have taken one number, y is another number. We squared them and we said that whose squares is maximum. We'll see whether it comes maximum or minimum in a short while. But the sum has to be maximum, and this equates to z. Z is the maximum or minimum, that we'll see just now. So how do we go about it? Because we have already formed two expression using the two sentences. Minima, maxima is always computed using the dy by dx, that is the differentiation. Differentiation is equal to 0 is what gets you the critical points. Those critical points are important to find out the maximum and minimum value. One value we have taken as x, the other will be 15 minus x. Two values are x square and 15 minus x whole square. So in place of x, in place of y, 15 minus x whole square. Now rather than opening it, it's better that you can just differentiate it right now, or you can open it. A minus b whole square, a square plus b square minus 2ab. Finally you got 2x square when we expanded, 2x square minus 30x plus 225. This is the expression we got after say expanding 15 minus x square. But the thing is that it can become easier if you just differentiate with x square plus 15 minus x square. That we'll see in the later questions also. Because this is the first question, I expanded it. I'm now differentiating it. 2x square will be 4x minus 30. 225 will be 0. So this dz by dx is 4x minus 30. In order to get it as maximum and minimum, we have to equate it to 0. That means 4x minus 30 has to be 0. X will be 30 by 4. And 30 by 4, if you just divide both numerator and denominator by 2, it will be 15 by 2. It's just the half of x. So what will be y? It will be again 15 by 2, because 15 by 2 will make 15. I'm not differentiating, redifferentiating. That is the second differentiation I'm doing. It gives you 4. That 4 is simply a positive number. And this double differentiation will give you the minimum. Now you will raise a question that maximum value or maximum only comes when you have negative, and positive gives you the minimum value. And we are supposed to find out sum of the squares is maximum. But we don't have to go to this d2z by dx2, because we have found the critical points and there is only one critical point. We cannot go here and there. We have no option left. We are just with x equals to 15 by 2, y also comes to be 15 by 2. And x and y is 15 by 2, z is simply 15 by 2 whole square plus 15 by 2 whole square. That will make the whole expression highest or maximum. So we can say that 15 is divided into 7.5 and 7.5. As I told you, they were just positive numbers. It was not mentioned it is an integer or a decimal number. So whatever we explained, it is here. Don't bother about d2z by dx2, that is the double differentiation. We just did it just to show that because maximum and minimum is required, sum of whose squares is maximum. So that is how we get the maximum minimum. And since it is coming as 4, I just rest my case and I just go with the numbers which we have. So there are two positive numbers, you square them, there will be positive square, and that will make them most maximum. Divide 64 into two parts such that the sum of the cubes of two parts is minimum. Again 64, as we just have witnessed, two numbers can be divided as x and 15 minus x in the previous case. One can be x, one can be 64 minus x. So if you have whole line like 65 numbers, if you take some of them as x, the rest will be 64 minus x. Either you can do x plus y equals to 64 kind of thing which we just did in the previous question, or you can say simply one is x, one is 64 minus x, which is more realistic also. And from this expression x plus y equals to 64, it will also give you 64 minus x. In both the cases, x and y will be x and 64 minus x. This is the first part we have completed. We have divided 64 into two parts. The second part is saying such that the sum of the cubes of two parts is minimum. Now we are not worried about minimum, maximum. We are more worried about the critical value which we get. So x cube plus 64 minus x whole cube, because the cubes are being talked about, and this is equal to z. Now let us just differentiate it. The next thing which comes is the differentiation. When we differentiate, you get x cube plus 64 minus x whole cube. In the previous question, we expanded 64 minus x whole cube. There are certain people who might not remember the cube formula just now. They will just recollect it, and that will take time. It's better that rather than expanding it as refer to the cube on the power, we can just differentiate it. So x cube differentiation is 3x square. 64 minus x whole cube is 364 minus x square, means square to this one. And 64 minus x is going to give you -1. So it will be 3x square minus 3 into 64 minus x whole square. This is the whole thing which you are going to get. Now the next part comes when we are already at differentiation. We have already done differentiation. The next one goes as equating it to 0. When we equate it to 0, those both part will be on either side. 3x square is going to give you 3 into 64 minus x whole square. Negative was already there, so we just transferred it. Now what will be the better way? Just cancelling this 3 and solving this, or rather there can be some other way also. I'm just expanding it. 64 minus x whole square, 64 whole square is 4096, x square is x square, and minus 2 into 64 into x is minus 128x. When we cancel this, we'll get x as 4096 by 128, and that will give you 32. 12, 128, so you're going to get 32 here. The other number will be y equals 64 minus x. So 64 minus 32 is again 32. We have seen in the previous question also that it was 15 by 2. So when we divided and we wanted it to be minimum or a maximum, then we already found that it has to be divided into two parts. Next one is d2z by dx2, that is the double differentiation of a differentiation. We are again differentiating it, and since we are already we have already done the differentiation part, we'll do the double differentiation as well. This double differentiation will give you the certain expression in which you have to put this x as 32 and try to find out whether we get negative or positive. Incidentally, we may get negative or positive, we'll just see. I'm just replacing this x by 32 right now. And this x equals to 32 is going to give you d2z by dx2. That will signify not the value but the sign. And that sign will indicate us whether it is going to be minimum or maximum, because the negative means maximum, positive means minimum, that we have learned in the previous exercises also. Once you compute this, what are you going to get? You are going to get a proper value, but we are more interested in finding out whether it is negative or positive. Negative and positive will give you the proper idea. But here, if you see, it's coming 384, and 384 is actually positive, and positive means greater than 0. Greater than 0 means we are talking about a minimum value. So there is a slight change, or you can say the previous question should be minimum, and that we have seen that previous also we got 4. So I would like to change the previous question and this question also. Previous question was minimum. If it would have been maximum, then the things have changed. So there was no mistake at all. This is all the correct thing which we have done. How should we choose two numbers each greater than or equal to -2 who sum this so that the sum of the first and the cube of the second is minimum? Now x and y, we have to choose two numbers each greater than or equal to -2. They can be equal to -2. They have to be greater than or equal to -2. There are the only two possibilities of choosing those numbers. The second thing the second part of this question is whose sum is half. This is given in the question, so I am writing it here. The question is saying the sum should be half, so that the sum of the first and the cube of the second is minimum. As we have x and y, that two values are the variables we generally take when we have two variables, x and y. When we have third variable, we take it as z also. But x plus y is given in this question as half. X plus y is half. Now you are getting x, you are getting y also. Y is simply half minus x. There are two ways. If you do x plus y equals to half, you have to take one more step. Coming to the third part of this question, which is saying the sum of the first, which is x, and the cube of the second, which is y cube, is minimum. So from here from the first part, you can say x we got, y is half minus x. Now we are replacing this x and y in the final equation, which is z equals to x plus y cube, which has to be minimized or maximized. Half minus x whole cube, rather than actually cubing it, it's better that we just differentiate it. Opening it will take time, and we have to eventually differentiate only. So thrice of half minus x whole square, x will be 1, so I'll just put a 1 here, and this 3 half minus x whole square will be 3 into half minus x to the power 2, and differentiation of half minus x will give you negative 1. Finally, what we got? 3 into half minus x whole square equals to 1. Half minus x whole square is equal to 1 by 3. Half minus x will be equal to plus minus 1 by root 3. It's root 3, I'll just change it, because when we take square on the other side, it has to be plus minus, and it has to be covered with a root, like a cap. So one time we got half minus x as plus 1 by root 3. One time we got half minus x as negative 1 by root 3. Now the question arises, which of these two values has to be actually used in order to find out which is the better value, or which is minimizing the actual expression, which is x plus y cube. Finally, we can write x as half plus minus 1 by root 3. I'm just combining the two values so that they go along. They go together. Next one is d2z by dx2, which is the simple differentiation of the differentiation. Double differentiation. That will give you the sign. So we are interested in the sign in this particular case of the second differentiation. I'm differentiating. I'm not saying what I'm differentiating, but you know that I'm differentiation of the second differentiation I'm doing. So this is the second differentiation, and this will simply be, because of course one is going to be 0 and half minus x whole square is already there. So it will be 6 half minus x to the power 1, and negative x half minus x differentiation will give you negative 1. Negative was already there, so negative will make positive. Finally, you will get 3 minus 6x. Now this 3 minus 6x, now you have to place half minus 1 by root 3 one time, and half plus 1 by root 3 one time. When you place half plus and half minus, you will see the sign. The sign where we get positive value, that will make this expression minimum. I hope you got the idea. In the previous two questions, we were talking about getting it minimum. So we got the positive values when we did the double differentiation. Here, it's simply certain values I'm putting, and when we place certain value, we need to have a positive value. And here we got the positive value. If it is coming as the positive value, when we place half plus 1 by root 3, we're going to ignore half minus 1 by root 3 straight away. This is the value negative. And since negative value and positive value, see, negative value will give you what? It means that it will be maximum. But positive value will give you the minimum. I hope you have the difference here. So please remember, in this half, I'm not saying what you have to put, and I'm not putting it also. I'm just saying half plus 1 by root 3 and half minus 1 by root 3. Just place that value, or place both the values, and take only that value which can give you the minimum value. That is, it has to be positive, and positive indicates the minimum value. 3 minus 6x is there. If I place this value, what are we going to get? See, if you place certain, again I am reiterating, I am not saying you to put certain value. I'm just saying to put value and find out the sign. The sign has to be positive in order to get it. When you place half minus 1 by root 3, you got positive. This is greater than 0. And greater than 0 means it is strongly recommending us that, oh, this is going to be minimum. So the whole story is half minus 1 by root 3. And x is this value. d2y by dx2, we got 6 by root 3, which was actually positive. And positive is indicating that this is going to be minimum. And we are interested in the minimum because the question is saying the x square plus y cube has to be minimum. So we are going to take that value only, which will make this as minimum. What is the x value? X already we got. Y is simply half minus of this value. So when we place this half minus of minus half and plus 1 by root 3, it is going to be plus 1 by root 3, because half of is going to get cancelled. Half minus half plus 1 by root 3, half of gets cancelled. You get 1 by root 3. 1 by root 3 is the final value which we are interested in. So this is 1 by root 3, and this x and y we have received, and these are the final values. You can just stop it here, because we need minimum. As I am reiterating again and again, this simple logic is to check for both the values, get the value which is greater than 0, and when you get that value, that is the final value which you can give it to x and y, and you can say that x and y are probably this value. So the required numbers are half minus 1 by root 3 and 1 by root 3, which will make this as minimum. Divide 15 into two parts such that the square of one multiplied with the cube of the other is minimum. Again 15 has to be divided. Again we are eyeing upon the minimum thing. So we have x and y. As I said, you can just do this in the way we have dealt with the question having 15 as the number. One will be x, the other will be 15 minus x. That is the whole idea which we pave upon, or which we walk upon. X and 15 minus x are the two numbers. This is the first expression, always run, because x plus y is 15. That is how we came up with x and 15 minus x. The second one is the square of the first, x square, and the cube of the other. What is the cube of the other? Minus y cube. So it's y cube only. No minus, it's just multiplication, because they are saying square of 1 multiplied with the cube of the other, x cube. And now I am replacing y by actual 15 minus x, which we have already talked about. 15 minus x whole cube. Now this square and cube, rather than actually multiplying and opening it, it's better because we have to differentiate eventually. Differentiation, we will take the product rule. First we'll take the first one, differentiate the other one, then we place a plus sign, then we differentiate the second one, place the first one, like that. Finally we'll get an expression. This expression we are not going to stop. This expression has to be placed or equated to 0 in order to get the critical point, and that critical point will be the deciding factor, and that deciding factor will give you the values which we started with x and y. Again I'm saying differentiation is all what I'm doing just for the sake of completion. Differentiation is your responsibility, which you owe me, because differentiation is already known to you. Now both the sides we have equated, and this is the way I'm doing. Most of the people will do it like this, and you will see that you will land up with a problem. If I cancel both the sides, like I divide both sides by 15 minus x, I divide both sides by x square, like this. But what you are going to get here, you will just see one value you will get, and that is the correct value also. You will see that what I'm suggesting here is the value you are getting by this just equating and cancelling things randomly. X is 15 by 2, that is 5, 6, 30. X is 6. What will be y? Y will be 15 minus 6, that is going to be 9. So x and y we got, but this is not the right way. I'm just saying that this will also give you the correct answer. But the whole idea is the mathematics is not done like this. We have to find out all the possible values, all the critical points, because x equals to 6 is just one of the critical points. Now what I'm doing is I'm taking the right expression to the left expression, and now I'm rearranging it and trying to find out trying to see, are there other values along with 6, or 6 is the only value. So I'm just taking these again on the left hand side, all of them. Now I'm taking 15 minus x common. When I take 15 minus x common, I'm pretty sure that x equals to 15 will be one of the critical point. I'm taking x outside, that will be x. So x equals to 0 is another critical point. And what is left inside? Whatever is left inside is what we have already done. See, 30 minus 2x, or 30, this will be 15x, 5x basically. Minus 2x and minus 3x will get combined. It will be 30 minus 5x. Okay, now when we are equating it to 0, x is equal to 0, 15 minus x equals to 0, and 30 minus 5x equals to 0. 30 minus 5x equals to 0 is already being witnessed by us just a few seconds back. But 15 minus x whole square and x was not there. I am saying you were on the correct path, but I am just saying that you have to tell the examiner that there are other values also which we found, but they are not relevant to the question, because 15 minus x will give you, if you equate it to 0, will give you x equals to 15. So when x is 15, y is going to be 0. You cannot take that. When you have x equals to 0, what does it mean? Y will be what? It will be 15. So you again cannot be taking that, because 15 and 0 is not the part. You have to divide 15 into such that it has to be two parts. So 6, 9, or say 5, 10, like this. So two parts that will give you the expression, and that expression has to be minimum. So now we got 6 and 9. I hope you got all the explanation which I gave. 0 and 15 cannot be taken. X equals to 16 can be taken, and y is equal to 9, because x is 6, so y will be definitely 15 minus 6. That will give you 9. The next step is to differentiate, double differentiate. I am not differentiating the differentiation. Again, I am not telling you what I am doing, because this is your responsibility. Double differentiation is simply the differentiation of the previous differentiation. When I differentiated it, and when we place x equals to 6 here, what is the value I am getting? I need to get a positive value in order to find out, or say strongly that we are going to get a minimum value. So when you just see after placing x equal to 6 in the double differentiation value, you get negative 2430. Negative is less than 0. Negative is less than 0 means you are going to get negative is maximum. Again, here is this situation here, because we are talking about minimum, but don't worry about that. Even if you are getting less than 0, z is maximum when x equals to 6 and 9. So the question I need to change, I cannot change because the question is like that. It is given already in the book. But when we take this d2z by dx2, we are not convinced. I am not convinced actually. So there will be certain questions which can deviate your intelligence. But I would suggest you that what all practice you have done, that is the single differentiation, double differentiation, placing it to 0 and finding out the sign of the double differentiation, that will land up you on the finding of x and y, which is the value which is to be placed here or to be found out. Don't worry about minimum and maximum here. The question in the exam will truly be tested and then it will be provided to you, because here negative simply means that you are going to get maximum value, which is not the case here. I hope the first question was like that, the fourth question is like that, and other questions will be like that. But our idea should be simply straight, differentiate, double differentiate, and then just find out the value. This question we are going to take in the next discussion. Thank you so much.